Alright, in this problem we want to rationalize the denominator. So we have a cubed root of a variable to the fourth power. So just down here off to the side, if we had the cubed root of r to the third power, the cubed root and the cube cancel and it simplifies to r, and the radical goes away, so it's rationalized. Basically, you have to have a power that's a multiple of the index, because also if you had cubed root of r to the sixth, you could split that into the cubed root of r cubed times r cubed, which could be split into a product of two radicals, the cubed root of r cubed times the cubed root of r cubed, or r times r, or r squared. And I have no problem if you want to jump straight from here to here, okay, once you understand. So that's what we're going to try to get in this one, because we already have 4 r's in that denominator. Okay, but before we can do that, we need to split this into a quotient of 2 radicals. It doesn't matter if the negative goes on top or bottom, so I'm going to put it on top just to get it out of the way. So we'll have the negative of the cubed root of 5p divided by the cubed root of r to the fourth. Okay, so we want to get r to the sixth down here, so we need 2 more r's under a radical. So I'm going to multiply by a fancy form of 1 of the cubed root of r squared over itself. That way, in the denominator, we have cubed root of r to the fourth times the cubed root of r squared, and we add those exponents, the 4 plus the 2, to get r to the sixth. Okay, down here, in the numerator, we have the cubed root of 5p times the cubed root of r squared, so we can combine those into a single cubed root as the cubed root of 5p times r squared. Okay, and that's really what I did here. If you want to see the steps in between there, because I did skip a few, what it is the cubed root of r to the fourth times the cubed root of r squared. They're both cubed roots, so we can multiply the radicands, r to the fourth times r squared, and that's how you get r to the sixth. Okay, once you have that, then the denominator simplifies to r squared. That's because of what I showed right there. Okay, and in the numerator, just copy what we have, the negative of the cubed root of 5p r squared, and none of that is going to simplify, so that would be a good final answer right there.